Okay, I think we can get started. Afternoon, everybody. So my name is Cormac Hogan. I work at VMware, and I work a lot on a product called vSAN. But more recently, as you've probably gathered from this morning, Kubernetes is making a big buzz at VMware. And so one of the things I've been looking at very closely is how Kubernetes and vSphere are integrating from a storage perspective. Now, I am going to talk a little bit about vSAN at the very beginning. We had a new release just in August, 6.7.3, along with a new release of vSphere. So I'm very quickly just going to cover what we did that was new there. One of the key parts that was new was building vSAN as a workload, or as a platform, not just for virtual machine workloads, but also for container workloads. Now, we realize not everybody is well versed in Kubernetes, so we're going to spend a little time as well going through what the primary Kubernetes storage constructs are and how they relate back to vSphere storage constructs. And then when we get a feel for that, we'll talk about a feature called Cloud Native Storage, which is essentially bubbling up what Kubernetes is doing on vSphere storage and making that visible in the vSphere UI. So there's a bunch of things to go through, but we have plenty of time. This is the plan or the agenda. As I said, I want to give you a quick overview of what we released in vSAN 6.7.3. Then we'll get into the Kubernetes construct stuff. Then we'll talk about cloud native storage and the drivers that we are building to go into Kubernetes to make that happen. And then we'll close off with an overview of something that's in beta right now. And I have a demo to show you as well. Now, although the agenda said vSphere storage, what I'm going to show you here about with cloud native storage is also going to be applicable for VMFS, for NFS, and going forward, we will make it work with vVols as well. Very good. Now, I start all of these sessions when I talk about vSAN by pointing everybody to storagehub.vmware.com, because this is where we put all of our vSAN documentation, the reference architectures, the how-to guides. Everything is up in Storage Hub. In fact, all of our storage documentation, which isn't the tech publication stuff, so all the stuff that's developed by the technical marketing team and so on, it's all up in Storage Hub. So I make a point of just highlighting this to everybody so you know where to go for additional information. If you're not aware what vSAN is, I'll give a 30-second overview. So we take a bunch of ESXi hosts. All of those ESXi hosts must have local storage. We aggregate all of that local storage together, and we build what's called the vSAN data store that's accessible to all the ESXi hosts that's in that cluster. And then how do we provision onto that vSAN data store? We do it through policies or storage policy-based management. So if you have a virtual machine that has a storage requirement that says something like RAID 1 mirroring for protection or RAID 5 or RAID 6 for space efficiency, put that in the policy associated with the VM, and when that VM is provisioned on that distributed vSAN data store, it is laid out in a way that meets the policy settings. So you go, that's about it, 30 seconds, I think. But of course, it's also integrated with all of our core vSphere features like HA, DRS, fault tolerance, all that kind of good stuff. Out of curiosity, how many of you are vSAN users? Okay, quite a few of you. It has been our most successful product since ESX. So now I think this might even be a little bit out of date. I think this was used at VMworld in the US. I think we were just around the 21,000 customer mark now. And yes, when we started off, we were very cautious. I know I've been to the UK VMUG many times and talking about vSAN many times. I know when it first came out, I was over here talking about be very cautious, be very conservative about how you use vSAN, maybe use it for test and dev, maybe VDI, something like that. But now you'll find it used pretty much everywhere and in all use cases. The other thing that's interesting is the dial home information that we're getting back now. So we have this customer experience improvement program. I don't know if you've seen that. You can enable it on the vSphere client. It sends back a whole bunch of metadata about how your vSphere infrastructure looks. And this is just some of the information we got back about how vSAN is being consumed by our customers. So it's really interesting. And as I said, you'll find it used everywhere today. So let's get into what we released in 6.7.3. So this was the release that came out just in August of this year, just in time for VMworld, I think, in the US. And so we broke the I suppose the goals of that release into 3 different buckets. The first one was to improve performance in a specific area, which I'll go into with you. The second one is, they call it intelligent operations. I call it not shooting yourself in the foot with doing certain operations on vSAN. So we'll get into that as well. The third bit then is all about making vSAN that platform for container and virtual machine workloads. So we'll leave that a little bit until we've run through some of what the Kubernetes storage constructs are. So let's talk about performance enhancements. So I've basically just lifted a few slides from a session that a colleague of mine delivered at VMworld. The session ID is up there in the top right-hand corner, so if you want to have a look at that in more detail. But essentially what we were looking at is how do we improve performance on vSAN when dedupe and compression are enabled, which in the past has been a bit of an Achilles heel for us. It's not as performed as best as we would expect. So the whole objective here in the 6.7U3 release was to make vSAN perform much better when dedupe and compression are enabled on the system. So with that in mind, you can see he had a pretty beefy setup here with NVMe devices and so on to do this testing. This is the first test he ran. It's basically random I/O. You can see the various details about the workload. I'm not going to go into it in too much detail. What is interesting, though, are the results. So here you can see from a IOPS and throughput performance improvement with dedupe and compression enabled on vSAN with random I/O workloads, we got a 15% increase in performance from a throughput and IOPS perspective, and the latency dropped by 20%. What is probably more interesting, though, is the standard deviation results. And so the standard deviation is that we get the average of, so this is basically what's going along the x-axis here is the number of outstanding I/O. So we're increasing the load on the system. And you can see with the previous release, the 6.7U2 release, which is the orange, huge amount of jitter from the standard deviation. So we couldn't actually predict, as we put more load on the system, how it would behave. 6.7U3, you can see that the jitter has come right down. So now we can predict that the latency will actually stay more or less constant, even with the load that we're placing on the system. So that was a main goal. And again, just keep in mind, this is dedupe and compression. The second area, or it's still the same area, but the second test was same configuration, but this time with sequential workloads. So you can think of things like cloning or backups and restores onto vSAN for this particular I/O pattern. What we noticed here is that the IOPS and the throughput improved by 44%. And again, the latency dropped 33%. So the takeaway from this, and you don't even have to watch his 1 hour session now, I can just give you this overview, is that if you're a vSAN customer, or you're planning to be a vSAN customer, and you're using deduplication and compression, then the 6.7U3 release is something definitely worth considering upgrading your system to. All right? Cool. So let's talk about the second initiative, and this is the stop you from shooting yourself in the foot with vSAN. Not going to talk about all of these. There's a whole bunch of things that we put in here, but there's a few in particular. First one here, I think, is the maintenance mode at 1 o'clock on the screen. So vSAN behavior up until this release, let's say, for example, you had a 3-node vSAN system, so 3 ESXi hosts. And we deployed a virtual machine with a RAID 1 configuration. So you get a mirror, first copy of the data, mirrored to a second copy of the data, and then we have a quorum or a witness on a third host. So we're using all 3 hosts to deploy this virtual machine. That virtual machine will remain available if there's 1 copy of the data available and a majority of components. So 2 out of those 3, whether it's the 2 data copies, 1 data copy, and the witness, whatever. The virtual machine will remain available. So we can put a host into maintenance mode quite happily. I mean, we obviously need to do maintenance mode. And in that 3-node system, you couldn't evacuate the components to any other host. So you're stuck with just taking that component offline. But that's fine, because now we have 2 out of the 3 hosts available, with 2 out of the 3 copies or components available, the VM is available. What do you think should happen if we decided we wanted to put a second host into maintenance mode? Do you think we should have something go, whoa, stop, you don't want to do that? Well, we didn't. and we just left you put that host into maintenance mode, and then your virtual machines will become unavailable. So this is guardrails around that particular scenario happening. Now, I took the very simple example, but you can imagine that this could be a 32-node cluster, and if you put the same 3 hosts into the maintenance mode that impacted 2 components out of 3 for a RAID 1 mirrored VM, you'll hit the same situation. So that's what that one is all about. The one at 3 o'clock then, the better resync behavior. The whole thing about vSAN is it's self-healing. So if you lose a node in the cluster and all of the components belonging to VMs on that node are now unavailable, well, vSAN will rebuild those components elsewhere on available nodes. The thing is, by losing a host like that, you've now reduced the size of the vSAN data store, because whatever local devices were available on that host are now removed from the capacity available on the vSAN data store. Thing is, we never took that into account with the resync, so we would keep on building, rebuilding, missing components, and end up in a situation where potentially we could fill the vSAN data store. So this is a guardrail preventing that one from happening. So there's a few other things here as well. I suppose one last thing I just highlight is the support down here at 7 o'clock for persistent group reservations. How many of you run Windows Server failover clusters or Microsoft failover clusters? Okay, quite a few of you. So the whole thing with Microsoft failover clusters is that they share responsibility for a service. And they have this scenario where if there's a split brain between 2 of the nodes, they race to put a SCSI reservation on a shared device. And this reservation, called a persistent group reservation, is put on that shared device. They both race to do that. Whichever node is successful in putting that reservation on the shared device or shared disk, that's the one that will take ownership of the service. The other one will just give it up. We could never put SCSI reservations on VMDKs that were sitting on a vSAN data store prior to the 6.7.U3 release. With 6.7.U3, we can absolutely do that. So now you can run Windows Server failover clusters on top of vSAN as well. So there's a bunch of other things here as well. I will say that everything is on Storage Hub. So if you wanted to find out about all the nitty-gritty details with all the different things that we've done in 6.7.U3, head up onto Storage Hub. There's a big write-up on all of these features. So the next thing then was this cloud-native storage feature. And this is essentially using vSAN for deploying using vSphere plus vSAN. And so you'd have vSphere running your Kubernetes cluster, and any of those container-based applications that require to do persistent storage can consume vSphere storage underneath. Now, we've been doing this for some time. The biggest issue is we'd no visibility into how these applications were consuming the vSphere storage. Whether that's vSAN, VMFS, NFS, it doesn't really matter. So this whole project was all about bubbling up how Kubernetes is consuming vSphere storage under the covers. Now, Joe Bagley stayed well away from Kubernetes, as you noticed in the keynote. Duncan and Frank talked about it a little bit if you were here for their session. I know Robbie, Jerome was talking about Project Pacific, and I think a lot of the time when we start talking about Kubernetes, we're sort of talking about it as if everyone has an understanding of what it's about. I mean, is there anyone here who would say that they're very familiar with Kubernetes? Is there anyone here who's sort of familiar with Kubernetes a little bit? Is there anyone who has heard of Kubernetes and hasn't a clue what the thing is? Okay. That's where I was about a year ago, believe me. So I've just been ramping up on that as well. So what we're going to start off with is just going through what actually Kubernetes is. So I think all of us have a good understanding of what a container is at this point in time. Containers is really just nothing more than a process, but things like Docker have done a really good job on packaging and making it easy to deploy and so on. But the Kubernetes then is, we keep hearing about these cloud-native apps. Oh, I can scale them in and out, and I can do highly available cloud-native apps and all that kind of good stuff. This is where Kubernetes comes in. So it's like the orchestrator of containers. There's been a bunch of these orchestrators. I mean, there was Docker Swarm that's still around. There's Mesos as well. But Kubernetes seems to be the one that has won that container orchestrated battle. Seems to be one that's the most popular, at least from what I see. Yep, so just by way of that, sometimes you see Kubernetes shorted to K8S. They might even be pairing that in this session as well, actually. But it's just K, 8 letters, and S is where they come up with, because they were too lazy to type out the full Kubernetes. But anyway, so again, I think if you were in these in this room for some of the earlier sessions, there was, Robbie was definitely explaining, where we're going from. Why is there such an interest in Kubernetes? And it's basically developers are driving this. I mean, most of us are coming from the left-hand side of the screen here. Somebody needs an application, it's fine. I'll build a VM, I'll install the guest OS, I'll get the ISO or whatever it is, and I'll put it inside in the guest OS, and then I'll turn that into a template, store it up in my content library. Somebody wants an application, no problem. A couple of Power CLI or Ansible lines of code, ta-da, the application is there. Fortunately, this right-hand side, unfortunately for us, I guess, this is where applications are being developed now. So there could still be virtual machines in the mix. There almost certainly is containers now, and you've heard about these functions as a service talked about as well, or FAS. I like to think of this as that kind of online bookstore. So you could have your repository of books, your customer billing information, all still held in some sort of database. That would be in VMs. Your front of store then, your web portal, your web servers, your ingresses, your load balancers, all of that could be in containers. And then you might be using functions as a service for something. When you put a book in the basket, it says, oh, customers who bought this book, they also bought these other books. So that's something that would run very infrequently, only when a customer puts something in a basket. So you may not want to have dedicated infrastructure for that particular part of the code. So what you might do is you might put that out onto some third-party cloud, whatever, and just call that as necessary, and just pay for it, pay for the resources as you call that very infrequent service. So that's where the functions might come in. And then the idea of the online bookstore, this predictive content delivery, is a very common use case for FAS. So you're saying, okay, well, is that actually happening? We're hearing about it from the guys here at the VMUG, but is it actually happening in the real world? So this is what the IDC are telling us, is that they're saying, if you think back to 1979, 1980, think of all the applications that have been developed from then till now. We're going to see more applications in the next 5 years. And what's delivering that is this method of developers able to break out applications into discrete components and work on those discrete components individually rather than working on one large monolithic application. So as they're working on these large monolithic applications, you might get one release a year. When they're working on these decomposed applications made up of discrete parts, they can fast fail quicker. They can release, become more agile, and release applications at a much faster rate. So now you're probably thinking, well, why are you telling us about this now? I mean, what have VMware been doing for the last few years while they've been able to see this kind of stuff happening? Well, actually, we have been. Have any of you used vSphere integrated containers, or VIC? Yeah, okay, a couple of you, very good. So vSphere integrated containers was nothing more than providing a Docker API endpoint to your developer. So they actually thought they were doing Docker, cool stuff. But at the back end, we still had virtual machines. So you had the security and the isolation of the VMs. And then at the front end, your developer had the agility of using a Docker API. One of the big myths about 3 years ago was that containers were for stateless applications. In other words, you stood it up, you did some units of work, you took the result away, and then you threw it all away again. Now, there certainly is a use case for that, but there's also a use case for persistent storage in containers. And that's what Project Hatchway was about. And all that was essentially was the ability to build VMDKs on behalf of containers so that they could store data, persist data. Now that sort of morphed into something else. We continued to build on that and included with that driver that allows Kubernetes to actually consume volumes on vSphere storage, we have the CNS feature, which is bubbling up what Kubernetes is actually doing on vSphere storage as well. We also have enterprise PKS, or any PKS customers here? Yeah. So PKS is essentially our easy button for deploying clusters on vSphere, Kubernetes clusters on vSphere. And it's integrated with the likes of vSAN, NSXT, and so on. Now, if you're here for the session just before lunch, you'll be aware that there's a lot of talk now about Project Pacific, which is essentially the merging of vSphere and Kubernetes together. I'm not going to spend any time on that. There was a whole session on it previously, and I think everything here has been recorded, so you'll be able to watch that back. So Kubernetes. Let's talk about the Kubernetes building blocks. So we still use this concept of cluster to talk about Kubernetes. And inside in that cluster, there are two distinct areas. There is the control plane for managing the whole of your Kubernetes deployment. And then there are your workers. And your workers are essentially where the container workloads run. So you have the management plane, you have the worker plane. Now, from our perspective, all of these are just VMs. So each one of these boxes that I draw in the control plane or I draw in the worker plane, these are just VMs. So these, in the control plane, these are typically referred to as the masters, and there's always an odd number of them just for high availability and so on. What they run is a thing called etcd. etcd is nothing more than a key value store for keeping track of all the things that are going on in Kubernetes. You can think of it as the Kubernetes database. How everything interacts with that etcd is through a thing called the API server. So everything that we deploy out, like nodes and pods and so on, they're all looking at this API server to see whether anything has changed. In other words, has a Kubernetes administrator or developer asked for something new to be created? Oh, I'll watch the API server and that will tell me whether something has happened, something new has happened. And then we have a scheduler, and the scheduler is simply there to pick a worker node on which to run something. Okay? So that's, in a nutshell, the master part. What you have then in the workers is another bunch of VMs. They're typically Linux as well, but you could have Windows here. And these all have an agent, a Kubernetes agent, that we call the kubelet. And the kubelet is watching back for the API server to see whether there's any requests for this node to do something. Okay? And what do we run on those worker nodes? They're container workloads. But Kubernetes has another term for these container workloads, and these are pods. So a pod will contain one or more containers. Okay? And that's sort of big picture stuff, but obviously Kubernetes doesn't run on thin air. So there is some infrastructure underneath. And so all of the infrastructure providers like VMware or Google or Azure or Amazon or whatever, they all have to provide or build a Kubernetes driver that allows the Kubernetes cluster to consume resources in the infrastructure. And these are what are referred to as cloud providers. Even if it's on-prem, it's referred to as a cloud provider. And so that's it in a nutshell. But because it's made up of just VMs, you could have very many of these clusters running side by side. Your production cluster, your UAT cluster, your test and dev clusters, all sitting side by side on the same infrastructure. But in essence, those are the main building blocks of your Kubernetes cluster. Now, if you want to learn more, the Kube Academy, Kubernetes Academy, I think they might have changed the name. There's the URL. If you want to learn more, it's all free. It's run by VMware, a bunch of folks that we acquired called Heptio, and they're building a lot of 101 sessions that will get you up to speed on Kubernetes, especially if you're coming from a vSphere side of the house. So those are the main building blocks, but what we haven't delved down into yet are the storage part of things, because I think we need an appreciation of the storage parts of Kubernetes before we can actually get into what cloud-native storage does. What you'll find in Kubernetes is that this thing called YAML is used everywhere. Yet another markup language. I know it's like going back to the 90s, but this is what they use. So what you do is you build this YAML manifest file. You have a command line tool called kubectl. You go kubectl, this YAML file, and that interfaces to the API server to say, here's what I want you to do for me. These are the pods that I want you to deploy. This is the storage I want you to create. This is my application is described in this YAML file. Go ahead and build it for me. Okay? So let's talk about the storage kind of things that you would see in the YAML files. I suppose at the most basic level, what we're looking at is a persistent volume. So a PV or a persistent volume is essentially attaching a container volume to a pod that can be used by the containers within that pod. Now, because the pod is running in a virtual machine, what happens from a vSphere perspective is that we have a VMDK that gets attached to a virtual machine, a Kubernetes worker node, and then the pod or container inside in that virtual machine is able to mount that file system, that mount point, that disk. So at the end of the day, if you're talking about Kubernetes running on top of vSphere, and you're talking about persistent volumes in Kubernetes on top of vSphere, it's nothing more than a VMDK on vSphere storage. Now, obviously, you don't want to be doing VMKFS tools and building individual VMDKs to allow Kubernetes to consume them. So Kubernetes has developed a dynamic mechanism for creating persistent volumes. And this is a persistent volume claim. So a persistent volume claim is nothing more than a request to build a VMDK dynamically. So if you have a concept of PV, PVC, we're halfway there. So this is an example of the YAML file that you might see for a PVC request. So there's a few interesting things in here, but really, I suppose the takeaway from this one is the section at the lower half of the screen where you're actually saying, I want you to dynamically build me a persistent volume / VMDK that in this case is 20 gigs in size. But where am I going to build it? I have vSAN storage, I have VMFS storage, I have NFS storage. How do I tell the vSphere infrastructure I want this VMDK, this persistent volume, created on a vSAN data store? Well, this is where the storage class comes in. Now, I ignore the name vSAN in that storage class. That's just a label. It doesn't actually mean vSAN. And what we're going to do is we'll explain storage class next, because this is basically, we know we want to build a persistent volume. Where am I going to build it? On which vSphere storage? So let's look at this storage class next. So the storage class looks something like that. Again, more YAML. But what we have in here now is the provisioner. And the provisioner is just the VMware driver. This is that cloud provider that sits between Kubernetes and vSphere. And you can see the kind of things you can put in here. You can put things like, well, the data store or the policy or so on. Now, in fact, all I needed in here is a policy. I didn't need the other things. So if I included the storage policy name as gold, this is a reference to SPBM back in vSphere, the storage policy-based management. Now, it just so happens that gold does refer to the vSAN data store, but I could have built policies around tags. I could have tagged VMFS, I could have tagged NFS, and I could put those policies in here as well. So now we have persistent volumes, which are nothing more than VMDKs. We have persistent volume claims, a dynamic request to build a VMDK, a storage class. Where am I going to put this persistent volume or VMDK? So now you have a pretty good grasp already of how constructs in Kubernetes relate to constructs in vSphere. But there's one really important thing that we're going to talk about next, and this is the ability to scale in and scale out applications that are deployed in Kubernetes. One of the constructs that are used in Kubernetes to scale in and scale out applications with persistent storage is what's called a stateful set. So a stateful set might look something like this, slightly simplified, but in the lower half of the screen, it just looks like a persistent volume claim, right? And in the upper half of the screen with that specification, we're saying In these pods, in these containers, when I get a persistent volume, I want you to mount that persistent volume into the container at this mount point. But the fact that we have built a stateful set means that I can scale it out, and scaling it out will build pods and persistent volumes every time. So you'll get a new pod with a new persistent volume each time you scale it out. If you scale it back in again, it just discards the old pods, the old persistent volumes. So this is a concept in Kubernetes that allows you to scale in and scale out, but it also scales the persistent storage with the pods. Now, one of the things I didn't call out, if you look in the spec at the lower half of the screen there, there's the access mode. And we've seen in the persistent volume claim, and now again in the stateful set, that the access mode is set to read-write once. That means that this pod, or only one pod, should we clarify, only one pod can use that persistent volume. That persistent volume cannot be shared. Now, most block storage that's consumed by Kubernetes is read-write once. It cannot be shared. But there's definitely a need to be able to share volumes, be able to share state and so on between multiple pods. And this is typically achieved through NFS. So NFS will allow a volume to be created with an access mode in Kubernetes speak, which is read-write many, not read-write once. So what we have here is a persistent volume, any persistent volume claim, which are tied to each other with a storage class label. So this storage class doesn't actually exist. It simply ties the persistent volume to the persistent volume claim. So any pod that uses this persistent volume claim will be able to mount that NFS server mount point into it. So just that distinction between read-write once and read-write many. So what have we covered? Persistent volumes, nothing more than a VMDK. Persistent volume claims, a dynamic way of creating a VMDK. A storage class, which data store should I be going onto? We looked at stateful sets, which is the ability to scale out with compute and storage at the same time. And then finally, we looked at the access modes, read-write once and read-write many. That covers the vast amount of storage-related knowledge you need to know about Kubernetes. Yep, there's a few bits and pieces as well that maybe fall outside the scope of this, but in essence, you pretty much have got pretty much everything there. So that brings me on to CSI and CNS. So CSI is our new driver for Kubernetes, and I'll explain why we needed a new driver. CNS, well, that's bubbling up the information that I've just been describing to you about how Kubernetes is consuming storage. Now, this is just to back up that claim that I said stateless containers, or containers are only for stateless applications, that was a myth. This is taken from a company called Datadog, who do a lot of metrics and surveying of applications. So 7 out of the top 10 applications actually require persistent storage. 7 of the top 10 containerized applications require persistent storage. So yes, you could use cloud storage, but customers came to us and said, we want to do this on-prem as well on vSphere. And so this is where Project Hatchway came about. So Project Hatchway, that very initial driver that we had, not just for Kubernetes, but also for Docker, was nothing more than the ability to build VMDKs on behalf of container volumes. There was a problem, though, with this Project Hatchway. This Project Hatchway was embedded in Kubernetes core code, along with AWS cloud providers, Google cloud providers, Azure cloud providers, Red Hat OpenShift cloud providers. They were all inside in the code. That meant two things. Kubernetes code was just bloating and it was becoming unmanageable. It also meant that every time we wanted to make a change or enhancement, we had to wait for the next release of Kubernetes. We could not release updates asynchronously. So it was decided a number of years back, everybody who has got providers in Kubernetes core code, get them out, and we're going to build this plugin mechanism called CSI. And so with the 6.7 U3 release in August, we released our first CSI driver plugin as well. And it's this CSI driver that allows us to bubble up all of this information that I'm talking about in CNS. And so CNS, which came out in 6.7 U3, you require that CSI driver, but it's giving you a whole bunch of insights into how Kubernetes persistent volumes running on vSphere storage, how it's being consumed, who's consuming it, what cluster they're on. I'm going to show you a demo in just a sec. This is a little bit about the architecture. I wouldn't worry about this too much. At the top, you do need the CSI driver. It won't work with the original cloud provider. Be aware of that. Down at the bottom, FCD or first class disks. A small explanation about what they are. We realized that when we're working with container volumes or persistent volumes, we needed to do operations like snapshot, maybe clone, maybe migrate at the VMDK basis, at the persistent volume basis. Could we do that today? Think about you do a snapshot of a VMDK today, you have to snapshot the whole virtual machine. Yes, there's ways around it, but it's tedious. But essentially, if you do a snapshot and you want to snapshot that VMDK, you're basically going to snapshot all the VMDKs. Similarly with storage vMotion, we don't have a concept of storage vMotioning individual VMDKs. We have to storage vMotion the whole VM. So you can see that there was a need to be able to do operations on a per VMDK basis. This is what first class disks were about. Now they've been there since about 6.5, I think, but never really had a use case. This is the very first use case for first class disks, meaning that we can operate on Kubernetes persistent volumes individually. So just keep that in mind. So great. I mean, this morning now we've been hearing about vSphere, great platform for Kubernetes. Let's talk about this. So here's my vSAN platform. And you might go back after this vMug and you say, well, I heard Cormac banging on about how easy it is to deploy Kubernetes on vSphere and vSAN. So let me go ahead and do that. It's very straightforward, actually. There's lots of ways to do it. Enterprise PKS, you can do it natively. There's all sorts of ways of getting Kubernetes deployed as a set of VMs. So now your developers here, oh, Kubernetes, great. I'll have a bit of that. So they start deploying out workloads and pods, and they realize that they can do persistent storage. So they have loads of persistent volumes deployed as well. And now they come along and say, my app is running slow. Can't possibly be my software. It has to be the infrastructure. And so now, thanks to 67U3, CSI and CNS, we have a way of looking at that. So what I have for you now is just a demo of the CNS thing in action. All right. So this is my vSphere cluster. It is also using vSAN for underlying storage. And I've already gone ahead and you can see here the Kubernetes master and 5 workers are deployed as a set of VMs. So the first thing you're going to think to yourself, well, that developer has probably gone nuts and filled up the vSAN data store. That's probably why things are running slow. So why don't we make that our first port of call? So I can come down here and look at the capacity. So what we've done with the vSAN capacity view, actually they haven't filled it up, surprise, surprise. But what we have done with this new vSAN capacity view is we have the ability now to determine how much of that vSAN data store is consumed by VM workloads and how much is consumed by container workloads. What's really interesting, though, is persistent volumes can live outside of pods. So you can actually destroy pods, and the persistent volumes that were attached to those pods can continue to exist. So what we can do is we can break it out, and we can show you the persistent volumes that are attached to pods and persistent volumes that are orphaned or whatever is still hanging around. But anyway, it doesn't look like there's anything with a storage issue there. So I'm going to go to container volumes, which is a new entry in 67U3, and I can see the container volumes overview. And oh my God, they've deployed all sorts of stuff. How on earth am I going to focus in on what's applicable here? What is very interesting, though, is that Kubernetes uses labels everywhere. Everything has a label. So whether it's an application, whether it's a dev application, a UAT application, a production application, labels are used everywhere. So we have this ability now through the vSphere client to actually filter out on labels. And you actually have another conversation with the developer, and he says, well, it seems to be the Cassandra application that's running slow. Okay, so let's just focus in on the app that is Cassandra. And there's only one of those persistent volumes for Cassandra available. So now straight away you can focus right in, and I'm going to show you that this will actually take you off to something else when we come back shortly to drill right down into how that persistent volume is deployed on vSphere storage. But you have a chat with this guy, the developer guy, and go, well, a single persistent volume means you probably only have a single pod deployed. Do you not think we could try scaling out this application? So yeah, okay, we can try scaling it out. Let's see what happens. So this is the Kubernetes dashboard. So this is like a Kubernetes admin's view of what's going on in Kubernetes. And because we know it's Cassandra, I can actually focus the namespace, which is basically an isolation mechanism in Kubernetes. So I can just look at the Cassandra namespace. And here in the Cassandra namespace, there's a single pod. It is a stateful set, so that means we can scale the compute and the storage together. But actually, if I drop down further and look at my persistent volume claims, my dynamic requests for persistent volumes, there's only one of those as well. Okay, so we're going to scale it out. We know it's a stateful set. Let's go into the stateful set. You can see labels everywhere, we said. And we know it's a single pod, and we can see events. So what I'm going to do, now you probably typically wouldn't do it this way. You would do it through kubectl or kubectl at the command line, but this is just another way of doing it, which I guess makes it a bit more visible. So I'm going to scale this thing out from a single pod and a single persistent volume to 3 pods and 3 persistent volumes. So let me just refresh this. Should I do it in the right place? So there's the second one is up, and I'll just refresh that once more. And so now I have scaled out to compute. I have 3 pods now for this Cassandra application. I can drill down, and I should also have 3 persistent volumes. You can see them there. You can see the persistent volume ID. Now if I go back to vSphere, and I keep my filter on, and I refresh here, I see exactly what that developer has done. I can see that he's scaled out the application from 1 persistent volume to 3 persistent volumes. Now, the more interesting information that we bubble up, you can see here, because we can click on any of these persistent volumes. We can see the Kubernetes cluster. We can see the persistent volume claim. It's basically allowing you as a VI admin that has someone running Kubernetes on that infrastructure to be able to have this one-to-one conversation with that person. Other interesting things here then is you can tell which worker it's on, which virtual machine this VMDK is attached to, because remember, for a container to consume it, it has to be attached to a virtual machine, vSAN data store, and so on. Even better, I can click here, and this is vSAN specific, by the way, at the moment. I can go straight into the virtual objects view. I can see this persistent volume is attached to that Kubernetes worker. I can see it's healthy. I can see the policy. And in fact, I can view the placement details. Looks like this is a RAID 1 VMDK, so whatever policy or storage class was consumed was a RAID 1 policy. It's got 2 copies of the data, both on different hosts, and the witness on a 3rd host. And you can actually even see which disks that it's sitting on. So you have that level of visibility now, so that if your developer comes to you and says a certain part of the application doesn't seem to be performing as well as expected, you can drill right down and see where on the vSphere storage, in this case vSAN, that resides. So it's pretty interesting. Now, let's just go back to the slides. There's only a few things left. It's not just for vSAN. So you can also build policies that tag your VMFS, build policies that tag your NFS. And so when you build your storage class, you can also consume VMFS data stores, NFS data stores. vVols will be coming soon. Anyone using vVols here, just out of curiosity? Very good, okay, excellent. Okay, one final thing, 2 minutes left. This is about vSAN file services. Remember we talked about read-write-many, the volumes that are read-write-many. This is something that we're building that will address that, but will be built on top of vSAN as well. So for the longest time, for the last 5 years, we've only been doing block storage on top of vSAN. File services, first in the form of NFS, will be coming shortly. So the one thing I am at pains to point out, actually I'll just populate that. So what we'll do is we will build VMDKs which we'll then be able to export as file shares, which can be consumed by other virtual machines, but of course by containers as well, and containers running in Kubernetes. What I do want to point out, though, is that this is not a NAS killer, okay? I just want to set your expectations, and I suppose we're taking that stance that we took 5 years ago when we first released vSAN. We want you to be very careful and do proof of concepts and see whether this actually meets your expectations. I don't want you to think that this going to be, oh, I can get rid of all my isolons now or whatever, okay? But yeah, just on that one, the whole thing will be managed through vSAN, through vSphere. So all of the setup, all of the configuration, integrated with the vSAN health checks, integrated with all of the other stuff that we have with vSAN as well in the vSphere client. So initially, NFS version 4.1, possibly NFS version 3 at the same time. But I do have a question for the audience. Out of the 3 protocols that we might do next here, NFS version 3, SMB or Windows file shares, or S3, just with a show of hands, who would prefer to see NFS version 3 next? 1, 2 maybe, okay. How about Windows file shares on vSAN? Quite a few of you, yeah. And then finally, who would be interested in an on-prem S3 object store? A few of you, so it looks like Windows file shares here. Perfect. And with that, I think we're right on the button. Folks, thanks for coming to the presentation. I hope it was useful.